A sigmoid function is a mathematical function having an S-shape. Often, sigmoid function refers to the special case of the logistic function shown in the first figure and defined by the formula. Other examples of similar shapes include the Gompertz curve and the ogee curve. A wide variety of sigmoid functions have been used as the activation function of artificial neurons, including the logistic and hyperbolic tangent functions. Sigmoid curves are also common in statistics as cumulative distribution functions, such as the integrals of the logistic distribution, the normal distribution, and students' t-probability density functions. Definition: a sigmoid function is a bounded differentiable real function that is defined for all real input values and has a positive derivative at each point. Properties: in general, a sigmoid function is real-valued and differentiable, having either a non-negative or non-positive first derivative which is bell-shaped. There are also a pair of horizontal asymptotes as the differential equation, with the inclusion of a boundary condition providing a third degree of freedom, provides a class of functions of this type. Examples: many natural processes, such as those of complex system learning curves, exhibit a progression from small beginnings that accelerates and approaches a climax over time. When a detailed description is lacking, a sigmoid function is often used. Besides the logistic function, sigmoid functions include the ordinary arctangent, the hyperbolic tangent, the Gauss-Riemannian function, and the error function, but also the generalized logistic function and algebraic functions like the integral of any smooth, positive, bump-shaped function will be sigmoidal. Thus the cumulative distribution functions for many common probability distributions are sigmoidal. The most famous such example is the error function, which is related to the cumulative distribution function of a normal distribution. See also, cumulative distribution function, generalized logistic curve, logistic distribution, logistic regression, logit, hyperbolic function, Eibel distribution, Heaviside step function, Gompertz function. References: Mitchell, Tom M. Machine Learning. WCBA McGraw Hill. ISBN A0-07-042807-7A. In particular see Chapter 4, Artificial Neural Networks, where Mitchell uses the word logistic function, and the sigmoid function synonymously This function he also calls the squashing function and the sigmoid function is used to compress the outputs of the neurons in multi-layer neural nets. Humphreys, Mark. Continuous output, the sigmoid function are properties of the sigmoid, including how it can shift along axes and how its domain may be transformed.